going to keep on waving. Waving not as in waving, but waving as in waving. Although this waving could look like that. If you talked about how far away your wave is from the center and it's displaced in a negative way and a positive way, it could actually be graphed to look like one of these waves. But anyway, same thing with a spring, because a spring could be at rest and it could be pulled down and then up and then down and then up and then down. And if you were to do that over time, it would look like a wave. Anyway, but there's sines and cosines. So now we have to talk about tangents and cotangents. So tangent, we talked about on Friday with the unit circle, because we have to review that over and over and over again anyway. So square root of 3 over 3, 1 square root of 3, undefined. Undefined's a vertical asymptote. So at pi over 2, we have a vertical asymptote. Tangent's going up in the first quadrant. It's getting higher and higher and higher. And if we were to keep on going past 60 degrees, actually, guys, help out. Calculator's open. I want degree mode. Radians, it's hard, because you're like, tangent can only be square root of 3 over 3 and 1 and root 3. But calculator's out, degree mode, degree mode. I want you guys to do tangent of, let's see, let's go past pi over 3, past 60 degrees. Let's do 70, tangent of 70, then do tangent of 80, then do tangent of 85. So tangent of 70, tangent of 80. You're plugging in all stuff. Tangent of 70, enter. Tangent of 80, enter. Tangent of 85, enter. Tangent of 89, enter. Tangent of 89.9. Enter. Tangent of 89.999. Enter. What am I having you get closer and closer and closer to? 90. And what's going on to your numbers? They're going higher and higher and higher and higher. Look! Higher and higher and higher and higher. Now go ahead and plug in tangent of negative 70 and tangent of negative 80 and tangent of negative 89.9999999. Just kidding. Anything in between. Go closer and closer and closer to negative 90. What's going on to your numbers? Down, 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 down. Now, unit circle doesn't show us that. Unit circle just shows us these three special in between. But what's tangent doing? Going down, 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 down. See, look at the tangent graph. Your calculator's telling you exactly what's going on. Pi over 2, vertical asymptote, positive infinity is kind of what's going on. At negative pi over 2, vertical asymptote, negative infinity is where my function's going. And then it repeats, repeat, 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 repeat. So what we need to think about with tangent is, number one, it repeats every 180 degrees, or every pi. That's its period. And it has vertical asymptotes at these 90s. But not at 0, 180, only when it's on the y-axis. So at 90, at negative 90, at pi over 2, at negative pi over 2. Or you'd have to go another 180 or another pi to 3 pi over 2. So it's not on every axis that it has vertical asymptote. So here's what we ended with on Friday. Okay, this guy can change. He can be transformed. But we don't have to do the whole amplitude and sinusoidal axis and the phase shift. We don't have to do all of that stuff today. What's important for tangents, at least, is that you find the vertical asymptotes and you find the period and the zero. Those pieces, and you do the correct swoop, there it is, you'll be all right. Unless it's vertically reflected, it's going to be going up. If it's vertically reflected, it's going to be going down. So check out this guy. If I was trying to find my vertical asymptotes for this, I would go ahead and take what's going on up here is you're taking whoever is inside the tangent, and you're setting equal to pi over 2. Taking whoever's inside the tangent, you're taking whoever's inside the tangent. So who's inside the tangent for this guy? X over 2. Be talking, it'll keep you awake. I know it's kind of warm in here. I don't want to make it cold for you guys unless I have to. So X over 2 is the inside guy. He's the inside guy. So we can say, okay, vertical asymptotes. Let's take X over 2 and say you're not allowed to equal pi over 2 plus pi n. We'll get back to that in a second in solving. Then we're going to figure out the period to know how far apart from one vertical asymptote to the next, because this one was every pi. So if I had one, I could go back a pi, forward a pi, go back 2 pi, go forward 2 pi. So period, I'm going to take this X over 2 and set him equal to pi. And then for my zeros, I'm going to take X over 2 and set equal to 0. If you want, you could technically switch the order and find the vertical asymptotes and the zeros and then the period, because the period tells me how far apart from 0 to 0 or asymptote to asymptote. But now let's go back and solve. So this is the easiest one, because isn't this one just x equals 0? Multiply both sides by 2. What's this one going to be? X is equal to, multiply both sides by 2? 2 pi. So I know my period already. I know my zeros already. Last thing I need is my vertical asymptote. I'm going to multiply by 2. If I multiply by 2, oh, do I have to distribute? So I end up with x is not going to equal, aka domain problem, which is how I see my vertical asymptotes, cannot equal pi plus 2 pi n. Oh wait, that makes sense, because the period says it's repeat every 2 pi. So what does that mean when I go to a graph? Well, that means that I need to have a 0 at 0. Okay, fine, whatever. 0 at 0, I can do that. 0, 0. I'm going to have first vertical asymptote at pi. And how far do I need to go to get to my next 0? Let me mark my vertical asymptote first. How far between? 2 pi. So 1 pi, 2 pi. 1 pi. I have to go to get to my next vertical asymptote. So I'm going to go 2 pi, so there's 2 pi. Oh, that's going to land me at 3 pi. And then I'm going to go backward. That's going to land me at negative pi. Now, if I was to put this one on top of that one, it's going to look pretty similar, except you guys see my tick marks were different, right? So this one has been a little bit spread out, but there's been no reflection, so it's going to just basically be, swoop, there it is. I'm not making you guys be super precise. Maybe I should make you find more points, but I'm not going to make you do more. I just want to know that you know the general idea of the zeros and the vertical asymptotes. And as long as there's no reflection, it's going swooping up. Do you guys see what I did, though? This looks confusing unless you just realize the tangent. Is that okay? Okay. Whatever's inside the tangent. Now, it is possible, especially with the zeros, if it's being added on the outside. You don't see that? Make it either more stretched or like a line or less. That's what the A is going to change, and I'm not making you guys show points to make it super specific. So A is not going to be a big deal unless it's negative, in which case this would swoop down. D could have a little bit of an issue because the D could change the 0. So technically I could say that I'm going to have my 0, whatever my x is, with my D. It's like in this one, the x was 0, so it was 0 with D, but D was also 0. So it kind of makes it a little bit hard. I don't see this very often with a D+. But the tangent could get shifted up or shifted down. And you would see by the number being added out in front. So the tangent could get shifted up or down. You guys do need to keep your eyes open for that, just in case there's a vertical shift. But otherwise, you can just follow my steps 1, 2, and 3 and have your zeros and vertical asymptotes in the right places, and then swoop, swoop, dun, 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 dun. Cotangent. How is he different? Cotangent is flipping tangent, right? So if I was to take my 0, root 3 over 3, square root of 3 over 3, 1 square root of 3, and flip them all, guess what ends up happening? In x over y instead of y over x. Instead of cotangent x is 0, cotangent's actually going to have vertical asymptotes on the x-axis, or when x is 0. Since tangent has vertical asymptotes when x is 0, this is going to have vertical asymptotes when y is 0. That's a better way of putting it. Another way of saying it is, when tangent is 0, cotangent would be, let's see, 0, pi over 6, pi over 4, pi over 3, and pi over 2. Tangent 0, cotangent would be undefined. Tangent is square root of 3 over 3 over 3. Cotangent is root 3. Tangent's 1, cotangent's 1. Tangent is root 3. Cotangent is square root of 3 over 3. Tangent's undefined. Cotangent is 0. Everything flips. So if everything flips, long story short, cotangent is going to have a vertical asymptote where tangent had a 0. Cotangent is going to have a 0 where tangent had a vertical asymptote. Everything is switched. But the nice thing is they both have periods of pi. They both last for the same distance. Just tangent 0 becomes cotangent's vertical asymptote, and tangent's vertical asymptote becomes cotangent 0. Everything switches. So his vertical asymptotes are going to be at x cannot equal 0 plus pi n. Tangent said, no, 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 no pi over 2. And cotangent says, no, 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 no 0. Or pi, or 2 pi, or 3 pi. Cotangent says, I have domain. X just can't be the VAs, like we put up above. Range, just like tangent. Cotangent goes forever low, forever high. But what's different is instead of like tangent counting up, cotangent, if you guys were to plug in, getting closer and closer and closer to 180, 160, 175, 179.99999, cotangent doesn't go up, cotangent goes down because he's the reciprocal of tangent. So whereas tangent was going up, cotangent's going down. And you can kind of see that in the cheater chart if you were to make it for him. If we were we'd have another vertical pi. And swoop down, there it is. Swoop down. So to be honest, guys, they're super similar in what you do. Because just like we did with tangent, for cotangent, we're going to look at the inside part. For vertical asymptotes, we're going to set that inside part, whoever he is, for the domain, we could say, which comes from the vertical asymptotes, not equal to 0 plus pi n. Wait, what is 0 plus pi n? Just pi n, right? To find, go halfway between the vertical asymptotes, or you could do what we did with tangent and just take the inside and say, hey, you're going to be pi over 2 plus pi n. Because remember, they switch places. The period, you're just going to set that guy equal to pi, like we did for tangent. So super similar, just the vertical asymptotes are now at the zeros and the period apart. And the zeros are not at the pi over 2s. They just switch places. Oh, I messed them all up. I know. I'm trying not to. Okay, so what's going on? He has a vertical stretch. What does that mean? I don't know. He's a little bit more of a line and a little bit less of a swoop. Yeah. But what am I needing to figure out? Okay, what does that change? I'm going to take that x over 3 and say, hey, you're not allowed to be at any zeros or pi n's. I'm going to take that x over 3 for my zeros and say, hey, anytime I have a pi over 2 plus pi n, and then my period, I'm going to say, hey, this whole process is going to repeat every pi. So the easiest one to solve, I don't know if it's easiest, but let's just go here. So my period, multiply both sides by 3. I'm going to repeat my zeros and my vertical asymptotes every 3. If I come up here and if I solve for x, x is going to not equal or have vertical asymptotes at 3 times 0 is 0 plus 3 pi n. And then if I multiply both sides by 3, I get 3 pi over 2 plus 3 pi n. What does that mean? Wait a minute, do you guys see that there's 3 pi n like all over the place? What's going on with that? What did I say the period shows me? How often the zeros and the vertical asymptotes occur? So technically, by putting the little pi n's in each of these, you're kind of accounting for the period. You could just do the period and forget the pi n's and say, okay, I'm going to start at 0, start at 3 pi over 2, and then move. Let me show you on the graph. Don't I have a vertical asymptote at 0? That didn't change. There was no horizontal shift, so I still have that. But I don't have another horizontal asymptote until how much later? Which the period would tell me, hey, you got to go over 1 and 2 and 3 pi to get to your next one. So I could do it this way, or I could just say move 3 pi. And if I want to get a vertical asymptote the other direction, where do I go? Negative 3 pi. Now where's my 0? Either halfway between, if that makes sense, or at 3 pi over 2. If I were to cut this, wouldn't that be 1 pi over 2, 2 pi over 2, 3 pi over 2? Which would also be 1.5 pi, which is right in between. And I can go negative, negative a half, negative a whole, negative 1.5. So sometimes the halfway in between trick works. Wait a minute, this isn't tangent. Oh, tangent swoops up. What does cotangent do? Swoops down. And because of that too, if you want, you can make it a little bit more like a line and a little bit less curvy. But I'm not going to stress and make you do lots of points in between. What do you think are some of the most important parts to tangent and cotangent that we need to get in a graph before we can finish off? Asymptotes and? I would say asymptotes and zeros, and how do we use the period? Yeah, where or how much space to skip in between. So what do we really need? The vertical asymptotes and the zeros. And to know whether swooping down or swooping up for cotangent and tangent. And then how do we know how far? That's tangent, that's cotangent. Are they hard if you knew all the characteristics? No. But kind of like sinusoidal waves, sinusoidal curves, it's going to take a little bit of practice, which is what this homework is for. So wait, if that's tangent and cotangent and we're done with them, then why did I think that we would? Do you see how I only have 1, 2? And they're super similar. Sines and cosines, they were both waves. We just kind of had to talk about how they're sometimes a little bit different in that sine starts in the middle and cosine starts at the top. But otherwise, they're super, super similar. Tangent and cotangent, super, super similar. Zeros and vertical asymptotes. Tangent and cotangent, super, super similar. Zeros and vertical asymptotes, but their graphs do look different. Because where tangent has a 0, cotangent has a vertical asymptote. Where cotangent has a 0, tangent has a vertical asymptote. Did I say the same thing twice? Anyway. So cosecant and secant, guess what? They're super, super similar. But what's different? Cosecant says, hey, remember me? I'm the reciprocal of, ooh. Who? Sine. And secant says, hey, remember me? I'm the reciprocal of? Undefined. Undefined. When tangent was undefined or cotangent was undefined, what was on their graphs? Tangent counts up and is undefined at pi over 2. Cotangent counts down and is undefined at 0. What's on their graphs at 0 or at pi over 2? Starts with a V and ends with a vertical asymptotes. Where's cosecant undefined? He's undefined when the y's are 0, right? where we talked about earlier on the x-axis. Secant is undefined when x is 0, which we already talked about, which is on the y-axis. Good. So what does that mean? Who else was over sine? Cotangent. What's cotangent equal? Quotient property. X over y or cosine over sine. Cosecant's going to have the same vertical asymptotes as tangent, and secant's going to have the same vertical asymptotes as tangent, sine over cosine. Okay, that's interesting. But you know what? That's actually a really hard way to graph them. And there's a really easy, no, I shouldn't say easy. There's an easier way. Not looking at tangent, not looking at cotangent, not even looking at the vertical asymptotes which happen when x is 0 or y is 0. I think the easiest way of graphing cosecant is the following. Realizing he's the reciprocal of sine, and similarly with secant, realizing he's the reciprocal of cosine. Wait, hold on. I don't want to spoil it and just give it to you. Can you guys get out your calculators? Can you change your calculators to radian mode? Can you change your calculator to radian mode? Zoom standard. And in your y1, I want you to do just cosecant. Who's what again? 1 over sine? Okay. I want you guys to graph cosecant. Who's 1 over sine? Zoom standard, radian mode. Well, it's kind of a parabola, but there's more to it than that, right? Are you guys in Zoom standard? So you ready? Cosecant, he's what? 1 over sine, right? If you guys graph sine, which starts in the middle, and goes up to 1 and down to -1 every 2 pi. And it goes backwards, following the same wave-like pattern, hitting again at 0 at -2 pi. If that's sine, doesn't cosecant, if I can find my marker, doesn't cosecant intersect, ooh, good math word, intersect at all the peaks and the valleys, all the maximums and the minimums? Do you see that? Yeah. And not only does it intersect, well, how would you guys describe it? What does it do? Yeah. It's exactly what I call it, Adam. It bounces off. It comes down, it bounces off, and then it comes up and it bounces down, right? Now guess what's happening in between each of these, what I heard someone say, each of these parabolas. Ooh, that's awkward. So what's happening in between each of these parabolas? Guys, what does sine, turn off the phone, what does sine hit? 0. Hey, wait a minute. 1 over 0 is going to be what? Undefined, aka? So in between each of these are understood vertical asymptotes. But check it, doesn't this make for a really easy graphing game? In order to graph cosecant, all you have to do is get your sinusoidal curve, which might be stretched, might be shifted, ooh, initial points and sinusoidal axes and amplitudes. You just have to get your sine curve from section 4.5, reviewing section 4.5. Jason, I don't want to make you stand up, thank you. I need you guys to hit at all the maximums and the minimums. So each of the maxes and mins are shared. Each of the zeros are vertical asymptotes, and then bounce, 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 bounce. Done! Lacey, are you in radian mode? Let me see. Oh, you didn't want to graph. I wouldn't have graphed cosecant and secant at the same time. I would graph cosecant with sine. So just graph this guy with him. Because they started getting all mixed in. And then see. So there's your like bouncing. And then your sine curve should go right. Yeah, see your sine right in between. There you go. And then I would clear out of that one to try it with secant instead. And it should look very similar. Yeah. Okay, so what do you guys think I'm going to do for the secant curve? Who am I going to draw? Cosine. And cosine starts at the top, right? and comes back to the top at 2 pi, and back to the top again at 4 pi. You guys agree?
Yes.
And then going back the other direction, comes back to the top at negative 2 pi. So what's secant going to do? Well, every time there's a max or min, secant's going to say, hey, me too. Every time there's a max or min, secant's going to say, hey, me too. Hey, me too. Hey, me too. Hey, me too. It's like an annoying little sibling. Hey, me too. Every time there's a 0, what's secant going to do? Every time cosine has a 0, what's secant going to do?
Bounces off.
No. Every time there's a 0, it's going to be a vertical asymptote, undefined, 1 over 0. That's bad, right? So I have vertical asymptotes every time there's a 0. And then what's going to happen in between? Bounce. 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 So what we need to do for secants and cosecants is basically make sure that we know how to do our sinusoids of sines and cosines. Get their curve, make it dotted, not solid. And every time there's a 0, an intercept with the sinusoidal axis, we're going to go ahead and make vertical asymptotes, and then we're going to say me too on all the maxes and mins, and then bounce, 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 and bounce. Done. Yeah.
On a calculator, it kind of says the actual 0 is an asymptote. It doesn't touch the 1 over sine, which is cosecant.
Yeah.
It goes to 0 and stops.
Well, it actually only goes to positive 1 and goes to negative 1 because it's bouncing off the sine curve. So, the secant itself, the secant will never hit there. And in between, your grapher I don't think shows vertical asymptotes, but in between your little parabolas that are like boing, 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 there are vertical asymptotes separating them. Does that kind of make sense? So all that to say, how do we put all this together? Wait. What am I telling you to do? If you're given a cosecant or a secant, what are you supposed to look at? The sine or cosine. So hold on. Let's take an example, okay? If to graph, you're supposed to look at the sine or cosine, well, you have to think about who's who. So cosecant, guys, who is he? 1 over sine. So we're going to say, first, y equals 0 plus 2 sine. Now hold on, is cosecant sine? Is this the same thing? No, but this is going to be my dotted. This is going to be my dotted graph that he's going to say, me too, vertical asymptote, bounce, 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 done. Actually, technically, it's me too, vertical asymptote, me too, vertical asymptote, and then bounce, bounce, bounce along the way. So in order to graph the reciprocal function, in order to graph cosecant, first. Then we're going to meet up at the maxes and min. Bounce, bounce. So what do we really have to do to finish off the last 5 minutes of class and get this graph done? Review, how do we graph sine? Oh, come on, how do we graph sine? Section 4.5, sinusoidal curves. Who do we start with? D, A, B, C over B? I'm even hiding the cosecant, just this guy. Review, section 4.5. How do I graph him? No, not A first. Who goes first? D. Oh, but where is he?
Nowhere.
Oh. Sinusoidal axis is just at... Oh. Isn't that just... He's here? Right? Okay. And what? Now A. How high, how low? 2. So I'm going to go up 2 and down. Okay. Remember this? Get our handwriting lines. Now what? Yeah, phase shift, right? Where's my initial point? Sine starts in the middle. Good. So 0 and negative pi over 4, right? Didn't that move left pi over 4? Well, hold on. We're not putting anything down until we figure out our units, right? And our units, we need to look at our period. How do I find period again? Wait, who's here? Just 1, I guess. Oh, okay. So period is 2 pi over 1, aka just 2 pi. So what are my quarter cycles? Yeah, pi over 2. So I'm going to say, okay, I need a pi over 2. Oh, wait a minute. But I have to go left pi over 4? I can go half of that, right? Okay. I can go half of that if I need it. Just going by pi over 2s, I suppose, then. Then I can go pi over 4, pi, 3 pi over 2. So I have my little pi over 4s halfway in between. 2 pi. Let's figure out what's going on. Sine starts in the middle at 0, negative pi over 4, which would be right there. True? Okay. And then how far do I have to go to get to my x? I need to go pi over 2, right? Which is 1, 2 pi over 4. Because of this whole little shifting left, pi over 4, everything's kind of off by 1. If we wanted to, we could go back and keep doing our wave, because it's just going to keep mimicking the same behavior. Okay. But why am I doing this dotted? That's so weird and confusing. Why am I dotting it? Am I actually graphing sine? Was that the point of this problem? What was the point? Oh wait, cosecant just bounces, right? Who does cosecant say me too to for a sine? Yeah, the maxes and mins. So you can go find the maxes and mins, and the cosecant says me too. Me too. What's halfway in between the me twos? What happens at the intercepts? What am I needing to make? So vertical asymptotes. Maybe we should write down that clue in a second, huh? So vertical asymptotes are through the intercepts. Wherever sine goes through, that would be an undefined. So vertical asymptotes are at the intercepts. The maxes and mins are me twos, and then what does cosecant do? Bounce. 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 Dun, 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 dun. What would your calculator show? All this work? No. Your calculator would just show the little parabolas. Boing, boing, boing. But what's going in between? The sine, and that's how we're going to get cosecant. Or if we need to graph a secant, who are we going to have to graph first? Cosine. But isn't it? Because then you're getting to know 4, 5 even better, and you're using it to graph cosecants and secants. So I don't know. What do you guys think would be good clues to leave off? I would say intersect at maxes mins. Do you guys agree?
Yes.
And vertical asymptotes at the zeros. Does that sound good? Graph the reciprocal guy. Graph sine. Graph cosine. Now, am I making you turn this whole thing in tomorrow by 7 a.m.? No, it's by Thursday. But guys, we're basically done with the section. So get as much done tonight as you can. We'll talk about questions. Homework's not due in Google Classroom until Thursday morning. Bye, guys. Get as much done as possible.